Hey guys, this is video 1.3. We're going to take, again, continuing along the line of changes in physical chemical properties of matter. We're going to talk about the changes now, okay? And it's one thing, it's very important to know is that matter is always changing. Okay, so ice melts in a drink, wood burns in a fire. So it's changing from one phase or substance to another. Okay, and that's kind of the difference here that we need to be able to understand before we can build off of that and kind of get into deeper stuff throughout the year. Is a physical change versus a chemical change. So again, definition stuff here. Physical change is a change that does not alter the chemical properties of a substance. Okay, so for example, something like cutting a piece of paper. Still paper regardless, doesn't matter how many times you cut it, it's still the same thing. You could, in theory, get it back to its original state and it would still be the same thing if you just put it back together. Another example would be something like a phase change. So going from solid ice to liquid water, all right, is still the same substance, still H2O, whether it's solidified, held together, or if it's broken up a little bit and kind of in the liquid state. It's still water. You can get it from ice to liquid very, very quickly, solid to liquid very quickly. Okay, so again, it's a change that does not alter the chemical properties of a substance. Okay, so it's something like a change in size or shape. The big thing you want to remember, guys, with a physical change is it's the same composition. Okay, same composition. Physical processes can be reversed physically. Okay, they can be reversed physically. So you can go back to its original state. So the example, like I said already, right, was ice melting to liquid water. It still has the same formula of H2O. Okay, there's still two hydrogens combined with one oxygen to keep it the same substance. It's just how the particles are arranged is what's changed. Okay, that's the big idea you want to keep track of with physical change. Now, a chemical change, on the other hand, is where you have a reaction. You're going to note right here, RXN is how I abbreviate reaction. You'll thank me later on. In which the composition changes. And the thing you want to remember, guys, with with composition, that's your chemical formula. And I can't write. Chemical formula. So if you change the chemistry of the substance, it's now a chemical change. All right, so reaction, which is composition of a substance, is changed. So an example of that would be something like rusting. So your properties have been changed, so now you have a different composition. Okay, different composition. Signs of a chemical change. You got to make sure you know these. Okay, color change, an obvious one. Doesn't happen all the time though. Okay, so it's not something that happens with every single every single reaction. Bubbling or fizzing. What would be, what would you know is happening, or what's being produced if you have bubbling or fizzing occur? That would be a gas is forming, right? It's being given off. Number 3, heat or energy change. So it's produced or used. So the temperature of your reaction is going to change, whether you started out hot and you ended up cold, or vice versa. And then there's a fourth one, and this is going to be a big one that we will devote pretty much an entire unit to, guys, is a precipitate. Okay, a I can't spell. Precipitate. And make sure you know this term through the entire school year. Precipitate, or is a solid that forms. I'm going to even highlight that. Precipitate means solid. You've got to know that. You're going to hear that a lot. Okay. So the example that we have right here, right? Firewood burning. The other thing you want to think about is, okay, chemical changes, you can't get back to its original state. So it's completely changed. It's no longer the same thing. It's gone. So think about it, right? That wood that you burn, you're not going to get it back, right? Because it becomes ash. So let's take a look here. Burning toast. What do you think? Is that physical or chemical? If you said chemical, you're absolutely correct. What about making ice cubes? We already said, right, that ice melting is physical. So the reverse of that would also be physical. This is where you guys can pause the video as I'm kind of going through some examples. If you see one or two and then do them on your own, come back to check the answers out. Lighting a candle, you're burning something. Anytime you burn something, it's a chemical reaction. Spoiling milk. Can you get that chunky lemon flavored milk back to its original state once you've let it spoil? Nope, it's a chemical change. Making Kool-Aid. What do you think? Chemical or physical? Is there a reaction taking place? Answer here, guys, that's a physical change. You could get that stuff back to its original state in that powder form if you distilled the water off. So you guys have a practice sheet right here. Go through, practice that, and check it with me or check it with the answer sheet, and I'll see you guys in the next video.